Hello, everybody. Welcome to yet another Solidity Fridays, except this time it's Solidity Fridays on Tuesday, because that makes sense. Or Monday, even, if you're in some parts of the world. In any event, I'm William Schwab. I'm joined by Ben Sparks and Rory Simmons from Linum Labs, and we have a special guest today who can actually read and write Solidity code, unlike us. Transmissions11 from Rari Capital is joining us to look at Rari Capital's own code. We started looking at the vaults a couple of weeks ago, and we'll probably keep on looking at some Rari code today. Welcome. So, Ben, you wanted to start off with a few questions?
Yeah. So we don't have like a very strict plan going into this, but like I definitely have a few questions on my side. Um, yeah, and like T11, just let us know if you want to like go in a different direction, if you want to just jump into code, if you have certain repos you want to unpack more than others. Yeah. But otherwise, I thought I would kind of start up with some questions if that's cool with you.
Yeah, let's do that. Nice to be here.
Nice to have you, man. So first, like, I was gonna just ask, like, who are you guys? What is Rari Capital? We see a lot on Twitter. We see a lot of sweatshop child labor jokes. So who are you guys?
Yeah, we're like a group of mostly younger people who we start off doing a yield aggregator. That is what's kind of on the Rari Capital website right now. We expanded into doing permissionless lending markets, and other fun DeFi stuff. We're kind of in the process of a merger with Fei Protocol right now, which is exciting. But I think the code base we wanted to focus on today was the vaults code base, which is kind of the rewrite of our yield aggregator with a focus on gas optimization and kind of ensuring that deposits and withdrawals are smooth, ideally no matter the size you're withdrawing, but in reality, we're trying to optimize for smaller users in most of the code paths.
Awesome. Yeah, and we can totally like focus on the Vault repo. Are you guys planning on deploying this stuff mostly, or I guess you're deploying it on probably a few chains, I'm guessing? Or is it mostly like L2s or mainnet? What's the plan there?
We're still figuring out kind of our multi-chain strategy, but mainnet's a given. L2s are probably a given. Yeah.
Awesome. And then I guess just for our audience, we often have a lot of people who are looking to get into Solidity, get into Web3 as devs. Maybe they have a little bit of like general software engineering background, but the idea of coding smart contracts is pretty intimidating. Do you have any advice for people like that? Any resources, any people to follow, any upskilling paths they should take? What was your
Actually,
plan as well?
if I could hijack that before you answer it, maybe. I think it was Jet who actually tweeted recently a conversation between the two of you where you were asking what a Solidity library is, which I think was probably around a year and change ago. So it seems like you've really done zero to hero in Solidity quite fast, being that, like, recently you had a whole, I'll give a shout out to Sam in the chat, but you had that thread going on trying to figure out like opcode optimization and constructors and figuring out, but like what opcodes making a constructor payable was eliminating. How do you have any advice on how to go from coming in? I mean, was Solidity your first programming language? Like, is this what got you into development? Did you have a development background before? And I guess either way with that, like, if you have any advice on just going really the whole gauntlet of Solidity.
Yeah. Okay. That's a pretty multi-layered question. I think I'll start with the background. Solidity was not my first language. I know a lot of great engineers or maybe not a lot, but I know one or two, like Ross Campbell from Sushi. He's a total badass, and I think Solidity was his first like programming language. But I started with Java. I kind of cruised my way through a lot of the kind of major programming languages, Go, Rust.
Java? How'd you end up with Java, man?
Dude, I was just looking for a first language, and I think I saw it on a couple websites. I honestly would not change a thing. I think Java is a great middle beginner language because you get kind of deeper exposure than you get with something like that kind of abstracts away everything like JavaScript, but you also get you're not like fully just like down with the pointers, like maybe if you started with C, though I think maybe if you really want to throw yourself in the deep end, C might be a fun idea. Yeah, so I got into Solidity. I was doing kind of web development at Rari. And you just touch smart contracts so much just doing Web3 front ends that eventually it was like, okay, I kind of get most of Solidity. It's time to just fully get into this. I think in terms of like mastering Solidity, the language is tiny. And that's kind of some of the beauty of it, in my opinion, is just how focused not on the tooling or a lot of the language semantics you are, but really just like the essence of programming and designing a system that you think is elegant. So in terms of kind of understanding it, I don't think tutorials are going to serve you well because there's not a lot of them, and if you find one, they're outdated. It's easy to get anyone can read the language after like a day or two. It's about finding kind of the patterns and the tricks that's going to take time. I think the key is just to read a lot of good code. Hopefully you might like this code that we go through today. Although it's a bit intense, but there's plenty of other great protocols like Yield Protocol, I think is great. Uniswap, obviously. Element Finance has some great code. I have kind of a list, but just reading a lot of great Solidity code and kind of understanding how they implement these great DeFi projects, and then trying to kind of think about those patterns when you implement your own code, and just write a bunch of Solidity, and then eventually you'll come up with questions when things start going wrong, or you look at the gas difference between two very similar looking functions and you're like, why is this different? And then you can pull up an opcode view with something like DAppTools, and then you can kind of, I think Twitter has been an invaluable resource, just nerd sniping fellow people to kind of, whenever I want to run into something kind of curious, I usually end up learning a lot more. And I think those moments of like curiosity are what always push me to a deeper level, like seeing, okay, this function is like way cheaper if I re-implement this tiny part in Yule. Like, why is that? And then I learn about Yule in that process, and then I'm more comfortable doing Yule in the future. And then from doing a bit of Yule, then I'm like, okay, look at the opcodes here. Like, why are they being compiled this way? And like, oh, how does the stack actually work? And like, when do you read and push to memory? All of that kind of just comes from being curious and kind of exploring wherever the software you write takes you.
That's such a
really
great point on the Twitter thing, and how it's been such a valuable resource for you for learning. Like, I can definitely say the same for my process. Do you have any recommendations of people someone should follow on Twitter if they're really looking to dive in and learn Solidity and probably get inspiration from the other builders?
Yeah, that's a great question. I wish there were more great Solidity devs like tweeting all the time about the shit they're building. I think Rari from the Solidity compiler team, he's been a great resource to me. So is Charles Cooper from the Viper compiler team. Paul Arberg, who works at Hi-Fi Finance right now, he's great. Edgar Arout, who does a lot of Mev stuff.
Edgar, I'm a break the chain.
What'd you say?
Sorry, internally we usually refer to him as Edgar. I'm a break the chain.
Yeah. Oh yeah, that drum was great. All the maker engineers, obviously. I think, yeah. Sorry, I'm like going through my own following list. Obviously, Samson, if you're still in the audience. Yeah, I think, and you'll like. I think I've come across a lot of them naturally. Like, there's not a ton of hidden gems maybe I could recommend, but I think usually the community is so small that if you tweet a really great question about Solidity, everyone's going to kind of find their way naturally. Oh, yeah, Chris from Maker as well. Those are kind of my obvious. Oh, Mudit Gupta, the classic. Brock Elmore, Matt Solomon, Ross Campbell, of course.
Cool.
Damn,
cool.
That's a great list. Yeah, I didn't know everyone on the list, but there's definitely like a lot of people I followed from that list that have been super valuable on my upskilling path.
Rai Wolholter is asking in the chat, actually, specifically around Yule. This has been something I've run into also. There's at least minimal resources for Solidity. A lot of people coming into the space hop into Crypto Zombies or something like that. Solidity documentation, actually, I find to be very readable personally. But are there resources out there for Yule other than the specification and the Solidity docs?
Yule is a pain to learn. Like, yeah, there's probably some great articles that don't have good SEO, and if you know them, like, please tell me. Like, there's probably something I could pick up from them, and I'd love to share it. But no, the kind of way I think the best way to learn is through Yule is through examples. Like, find some Yule code that you can almost make sense of, and then reference the docs for the parts you can't, or tweet. And you can slowly just expose yourself bit by bit to parts of the Yule language that are useful to you. And eventually you build up kind of a working vocabulary. Like, I think the main thing is holding back the need to feel like you know everything about the language at first, just kind of using the parts that are useful, because most people aren't writing their apps in Yule. Yeah, but kind of getting that first exposure is all that really matters.
And then potentially a last question to touch on before we dive into code. What are your thoughts on this multi-chain future that a lot of protocols seem to be going in, where they're just deploying on multiple chains, but then this interconnection between those different deployments seems rough at best. Like, there's like very rough bridging that goes on. And I know you've been kind of working on this Nova thing. Can you explain to us like what Nova does and how you guys intend to use it? And do you have ideas of taking that further and sort of a better dev tooling to deal with this multi-chain environment?
Yeah, great questions. And on the Nova front, Nova is kind of this abstraction over the kind of L2, L1 message passing system with some kind of relayers involved that basically allows you to kind of perform and validate contextless messages from L2 to L1 without the 7-day delay. So I know that's a lot of buzzwords. I'll kind of break that down. So there are actions that you might want to do cross-layer that don't need to. So if, for example, withdrawing 7 DAI from Optimism to Ethereum is a context-full action, because L1 needs to know about the state of L2 before it can process that withdrawal. It needs to know you burned your tokens on Optimism before it can give you them back on Ethereum. But an action that is not necessarily contextful is like, oh, I want to read this price oracle from L2. Read this L1 price oracle from L2 and then bring that data back to L2. Or like a Uniswap trade that like someone else brings the funds and performs the trade. So there's all these kind of actions that are kind of context-less that Nova can help achieve via this kind of relayer system that allows you to do all these really fun things, like buy L1 NFTs and wrap them up onto L2 and cross-layer Uniswap trades, all that fun stuff. Nova only works between systems that have a message passing bridge that actually is kind of ingrained in the protocol. So, for example, something like Nova from Ethereum to Bitcoin or whatever isn't going to work because there's no message passing bridge. Ethereum to what's it called, Polkadot, any kind of chain that doesn't have a bridge in between it, like, isn't something that can be kind of Nova-ified. And Nova isn't really useful for things that have a fast two-way bridge. So something like Polygon and Ethereum, the wait time between either direction, I believe, like, isn't that different. It's mostly useful if you've got the kind of 7-day wait time in one direction and then like a 5-minute wait time in the other direction, like you do with optimistic rollups.
Do these wait times get any better with ZK rollups as opposed to optimistic?
Yeah, like significantly. Like ZK rollups are something where something like Nova might not be necessary, though it depends on there's a lot of factors that go into how frequently like ZK rollup batches are committed. So it's kind of hard to comment generally. But yeah, generally like ZK rollups, the difference between deposit and withdrawal times is like much lower delta than optimistic rollups.
That's pretty hype. Because I'm looking forward to like a more cohesive multi-chain future for dApps and things where you can lean into the advantages of chains and L2s while have things kind of just like fluid between each other, and like if assets have a more liquid market on one chain, they can easily flow to that market.
Yeah, my guess for the long-term future is And I mean, I think this was kind of written in the original Ethereum sharding vision, basically, which is, I think we're going to have a bunch of kind of sovereign ZK chains that all interop with each other. So they're not bloating each other's state. And they can have kind of their own trust assumptions and all that to kind of maximize performance. But the tooling really isn't there yet, and neither are the virtual machines. But I think that we'll get there.
I mean, just maybe as a side thought with this, I think a lot of the thing with the multi-chain future is how much of it is a UX problem. I don't feel like any UX that, like UI UX that I've seen so far, really like kills how to do a multi-chain interface. Like, and just intuitively giving you the ability to move assets or anything else between between different chains. I think a lot of it might not even be a technical issue so much as just like providing an intuitive format for like getting things around. Like, we're already doing at least okay, I think, in terms of L2 scaling. I think a lot of it's also just going to be like how to present that to a user in a way that makes sense.
Yeah, I mean, Rainbow and Coinbase Wallet now are doing great things around that, kind of just
Yeah.
displaying things on the same page instead of segregating them entirely.
Yeah.
Yeah, in terms of like the multi-chain versus like multi L2 kind of future, I really am like a tech maxi, like at heart. That's kind of what I'm here for. So it's kind of hard for me to accept a multi-chain future when I feel like it's much easier to build interop stuff cross L2, and then also some of the kind of decentralization of some of these other chains just really isn't there. But ultimately, like at Rari, we're still kind of figuring out what to do there, because there is a lot of demand for like DeFi projects on lower security chains, and it's like, do we want to be providing that? We've even considered kind of franchising that out, which is something we've had Market XYZ do on Polygon. But yeah, it's still kind of an answer in progress.
That's super interesting on the franchising point. I know Sushi a while back. I don't know if it's still in works with all the stuff going on there, but they had that idea at the start of the year to do franchise liquidity pools. I think. Do you know about that?
I've played around a lot in the Trident code base. It's a great code base. But I have not had time to go high level on what those actually are. I don't think it's the kind of same idea I'm talking about here, though. I think it's kind of a different usage of the word.
Yeah, like different levels of like franchising. Yeah, what just as a side before I really do want to jump into the Vaults code base now, but we've got a lot of fans of Sushi. What are your thoughts on the Trident code base? Someone who's been quite deep into it and can actually like understand the stuff.
I think it's really nice. Like, I like that they they use our Soulmate ERC20 implementation in there, which is really fun. That was kind of the first major adopter, which kind of pushed me to keep developing Soulmate, because I saw it gaining traction. I think Crypto Noodles or something like that. He has like a cat profile picture eating noodles. He did a great thread on a kind of breakdown of the technicals between Trident and Uni v3. I think there are like some things that he said that they were kind of doing superior, but then there were also like some features that they leave out, which kind of opens the room for those improvements, like no sliding window TWAP, like Uni v3. So it's all trade-offs, but I think overall the code base is great.
Awesome. I'm very keen to see that deployed, hopefully someday soon. Yeah, I think well, if you're ready, I'm ready to jump into the Vaults code base.
Let's do it.
Quite keen.
Let's go. All right. So G11. Oh, sorry, I'm on pretty bad internet here. Can you guide us through this? We don't know what to really dig into or scrutinize here. Where do we start?
Yeah, okay. So if you scroll to that little diagram, there's kind of a high level overview. So the kind of idea is that users, they can spin up vaults for kind of any asset. Well, let's define vaults first. So vaults are little yield aggregator buckets where people put their tokens in, and then they kind of expect to wait a while and then pull their tokens out and have more tokens. And the idea is that those tokens are being put to work somewhere, like in a lending market like Fuse or Compound. And so the kind of idea behind the vaults platform is that anyone can spin up a vault for any asset, and then deposit into that vault. And then we have systems in place to kind of manage where those funds go, if there's good places to put them. That's kind of managed by all these little modules. So we'll probably want to start at the vault factory, where people create and kind of retrieve vault instances, and then we can move on to the kind of meat, which is vaults.
Awesome. All right, let's do that. Sorry, I'm just on my laptop. It's a bit clunky to navigate around, but yeah, vault factory, you say?
Yeah.
Let's go. Okay, how am I doing on Zoom wise? Can everyone read the code? It's all good?
So maybe enlarge it one more time.
More? Cool.
Yeah.
All right. Will, do you want to sort of guide us through this?
Can we take it? Yeah, sure.
Yeah.
Actually, one kind of general Solidity question that that I would want to just ask about general style here. Solidity style guide, if I remember right, or at least the way that I definitely remember seeing most Solidity code for a while, would kind of set up all of the global variables, all of the modifiers, all of the events, like all of the view functions, then all of the state setting functions and usually internal functions after that. But recently I've been seeing a style that you employ, which kind of chunks the code, and like each kind of category of what's going on in a contract you do separately. What made you guys kind of pick this style for writing your code?
Yeah, it's a good question. In terms of like the Solidity style guide, I don't really tend to follow language style guides unless there's like a huge thing in the community about that. Like I usually want to write code that I think is the most readable to me and the most maintainable, and that kind of emerged here. So the reason I like chunking things up so explicitly is because with smart contracts, it's more than like a Java program. There's a lot of emphasis on keeping things in the same contract, in the same kind of what would be in Java class, because you're going to have performance overhead from calling other contracts that are kind of separate in the EVM. And then from that, you end up with really, really large contracts, like 1,000-line contracts. And I want to be able to kind of easily split them apart in my brain as though they were separate files or, separate contracts. But for performance reasons, I don't want to do that. I also find inheritance gross because it's just not something I'm really into. Like you're chunking.
Can I interest you in some Viper, sir?
Yeah, I know, it's very nice. I have to get into Viper. I'm kind of held at gunpoint by Doggy right now because I suggested a feature and it got implemented and I'm supposed to try it out. But yeah, I think inheritance like encourages like chunking code into chunks that like are not meant to run solo, which is just very odd to me. But yeah, so this is kind of a way to chunk up code that like I can't actually chunk up for performance reasons.
Cool. So moving through this, it looks like you are still inheriting from auth, which is kind of the soulmate version of owner or ownable, right? Like, or it's a whitelist, if I remember right. It's been a couple weeks since I looked at it.
It's like a ultra flexible. It's like ownable plus more. So the idea is there is an owner who has kind of full executive control of the contract, and then there's also this thing called an authority, which is this contract that it has one function, at least that the auth instance knows about, called can call, and it takes the person calling, the function they're calling, and like which contract they're calling that function on, and then it responds with a Boolean true or false. So you can use that to implement basically any authorization pattern. So there's like a whitelist authority we've implemented. There are like role-based authorities. You could have like a time lock authority. So the idea with auth is kind of you have this super flexible authorization model that falls back to ownable.
It's a full-fledged access list.
Yeah, it's super neat. It's a pattern I kind of stole from DAppSys and DAppHub's work on DSauth, and kind of modernized it in Soulmate.
Cool. You want to scroll down a bit for us, Ben?
Sorry, I just lost my mute button there. Where you guys want to look next? Or T11, what's the important part of the code here? Or I guess it's all important, right? But what would you like to dig into first?
Well, one thing I just remember, I watched the recording of the last one, is there was a bit of confusion. If you go to the events, that like I'm kind of emitting, you can see that I'm like emitting a vault instance and an ERC20, or at least what looks like an instance of these types, right? Which I think is confusing to some readers, because in like a language like Java, we would associate that with an actual clone of the actual instance. Whereas in Solidity, contract kind of types are really just an abstraction by the language. They're kind of interfaces. They're not actually, they're never like these kind of heavy, expensive, like quote unquote objects. They're just kind of type syntax around really what is an underlying address. Yeah, just to clear that up, what that really is equivalent to is just an address. It's just something I like to do for type safety. So I'm not accidentally putting underlying in the event slot that's meant for vaults and vice versa. I think wherever you can to let the kind of type system make sure you're not making stupid mistakes in Solidity, like that is a great idea.
That's awesome. Yeah, I've started very recently. I think after going through this, I've started using these structs a lot more in my own code, passing them in as you do, as you see here, that you're passing in an ERC20 object as a parameter, and then sort of returning a vault object, and then also with the emits. So I'm doing that a lot more now in my own code, and I'm finding that a lot more readable, at least. I don't know what the gas optimization implications are, but at least for me, it's a lot more readable.
Yeah, in theory, there shouldn't be any optimization. Like if you replace them all with addresses, I think it should be around the same. Like there's no actual like casting going on at the VM level. It's kind of a type system thing. But yeah, I think it's definitely helpful for readability and correctness. Okay, and then like the meat of this kind of contract is the deploy function. The only kind of special thing is, it creates a new vault. It uses this kind of bracket salt syntax, which is a way to use the kind of create to opcode to deterministically create contracts like from a kind of salt. In this case, the salt, which is the thing that is used to determine that the address is the underlying token. We have to do this special fill last 12 bytes call on it, because a salt has to be 32 bytes and an address is 20 bytes. So we have to kind of fill the last 12 with 0 to fill it up to the 32. And that's a function provided in Soulmate's bytes 32 library, which is one of kind of the numerous utilities we have in there.
Nice. Yeah, I'm really enjoying just the sort of like background context of what Soulmate can do. Because I've started using the ERC20 from Soulmate, but I'd like to get more familiar with the rest of the utilities here. So it's super helpful, sort of just explaining the utilities that you're borrowing from there as we go through this. Awesome. So where next?
Yeah, let's just dive straight into the core vault stuff.
All right.
So that'll be the vault.sol. So this is really the meat. That last thing was like, I think it's like 150 lines. It's nothing compared to the like 935 line beast. Oh, I think you went back. Yeah. In reality, though, it's actually kind of shockingly small if you peel away all of my comments and line breaks. I kind of took an excessively, me and Jet took a very excessively commented and documented approach to this, because like ideally, like this protocol is seen as kind of a permanent protocol. There's no upgradability in it. So we kind of want it to last 1,000 years. And even if I'm no longer at the company or whatever the situation may be.
I usually like even adding something to that if possible, which is that for so many people, the way that they actually learn about a contract base or anything like that is actually directly through looking at the code on Etherscan. I mean, to some degree, NatSpec or code comments really are your docs. And a lot of people will not actually make it to docs. All they're going to see is the source code. And I mean, there's a lot of discussion, I think, in other languages about how much commenting is the right level of commenting. But at least personally, I feel like with Solidity, you really have to err on the side of commenting really as much as possible, because this literally may be the only documentation users see.
Yeah, and you know you're doing things well when you go to write the quote unquote docs, and it's just like, oh, I'm just copying my NAT spec.
Yeah. You may have seen recently. Tap 0x0 just put in chat also that Etherscan has added NAT spec support. So for people who are interacting with contracts through Etherscan, you're actually going to get the NAT spec there by each function, or like each little thing just built in right there. At that point, it really becomes docs. Like, it's literally what people will be looking at to understand what they're doing when they hit a function.
Yeah.
Yeah, cool. So we've got safe casting, we've got safe transfer, and we've got fixed point math coming in over here. How did you find the current state of fixed point math library? Sorry for cutting you off there, Ben. Like, you've got Paul Berg's, you've got some other ones. Did you write your own fixed point math from scratch, or are you implementing someone else's?
Yeah, so this was kind of a from scratch. So I'll kind of map out the space. So you have something like on the simpler end, you have people who just manually implement kind of fixed point math functions, which is just like, if you want to multiply two numbers that are scaled by 10 to the 18th power together, you multiply them together and then divide them by 10 to the 18th power to kind of scale it back down. The problem with that is it's kind of verbose and confusing, but then it's also kind of unperformant. And prior to Solidity 0.8, there were kind of overflow problems. So people built libraries like DS Math is one used throughout the MakerDAO code base, which has functions like wmul and wdiv, which are just kind of wrappers around that basic, like, multiply two numbers and then divide them by that kind of base. And then you also have, on the more complex end, you have things like Paul's library, which has more advanced math functions like logarithm, but it also has, for its like multiplication, the problem with something like the simple kind of basic fixed point math and even something like DS Math is, if the two numbers that you're multiplying together overflow, but like after you were to divide them, like it wouldn't be an overflowing value. You kind of get what they call phantom overflow. It's like, oh, the actual result like totally fits within a 256-bit integer, but the kind of intermediate result does not. So my contract reverts. People like Paul's and ABDK's libraries handle that intermediate state by storing it into storing the intermediate result in like two 256-bit numbers and then kind of casting it down safely. Like, Paul has really tried to advocate for that, like even under some of my tweets about fixed point mathlib. And I think it's good for some applications. Like Uniswap definitely needs it for some of their math. But I think for most applications dealing with tokens, you're probably not in a case where you're getting numbers, the intermediate values that are that high. So I don't think it's worth the performance head. So that's where something like fixed point math comes in, where we have the kind of typical simple math functions. And then the twist is kind of just that we do it all in assembly or UL. And it's actually surprisingly performant because Solidity Math has a lot of like overflow checking, a lot of division by zero checking where you don't need it, and other things we kind of, inefficient stack allocation we kind of found. So with the help of some nerd snipe Twitter users, we kind of wrote a fixed point math library that's something like, I don't remember the exact gas numbers, but it's at least like 25% faster, which is pretty significant. If you're doing like multiplication, like 4 times the function, that starts to add up.
Mm-hmm. Very cool. Cool. So just looking through over here, we've got the mutable base units. That's going to be the scaling factor for like you were referring to before. I assume each vault has its underlying ERC20 token, which we kind of saw in the factory. And so then in the constructor, we kind of have the code for like programmatically generating the name of the vault and of the asset. So you're following the classic kind of DeFi thing where like when you have a asset that's being deposited into a vault, you release asset, generally 1-to-1 or something like that, with kind of some kind of abbreviation. So you've got RV, so you'd have like RV DAI for Rari Vault DAI or something like, I'm assuming Rari Vault, unless there's some other secret thing that stands for.
Yeah.
And then the owner becomes, the deployer becomes the owner and is an authority also.
Well,
cool.
they don't become, the owner doesn't become, I mean, the creator doesn't become the owner, and the creator also doesn't become the authority. What that's doing is it's saying the creator is another authority inheritor, and I'm going to make my owner its owner. So it's basically saying like, whatever my creator has as its owner and authority, I'm going to take it. So that's how we kind of ensure consistency across all the vault deployments that there can be, and that they all like kind of share the same owner and all that.
Oh, so it's not, okay, the vault is being created directly by the factory anyway, right? I'm kind of, right.
This
so
actually breaks, it kind of breaks my heart to do this, but it breaks, you can't just, in EOA in the current form, unless you refactored a bit, couldn't just deploy Rari Vault. It would actually have to come from a contract that inherits.
Got it. So this means that if Alice is the owner of the factory, but Bob is the one deploying the vault, that Alice is still going to be the owner.
Yeah.
Got it. Interesting. Cool. I guess the value in doing that, as opposed to using the actual deployer, is it stops certain vectors of people deploying a malicious vault or manipulating a vault that they've deployed.
Yeah, I mean, it's also just kind of not in our design model. We don't really have a notion of like people who create vaults, like they're not relevant to, they're kind of just little helpers. They're not relevant to the system. The only people who should own or be in charge of vaults are people like actually chosen by the Rari protocol, or like the Rari protocol itself, like governance. So like just because you create a vault doesn't mean you should receive any ownership over it, at least in our kind of designs for it.
Cool. All right. So then, yeah, we inherit basic details from the deployment. Underlying is underlying. Base unit is 10 to the power of decimals. Where was decimals passed in? So it's not passed into the constructor.
Probably just a constant.
So it's set in, so the ERC20 constructor, since this whole vault instance.
Oh, got it. Yeah, underlying dot decimals. See it over there.
It's reading the decimals field of it.
Got it. Yeah, cool. Okay, and then this was cool. I noticed this the last time we were looking through this also. The way that you stop minting until initialized, just by using type max there. I thought that was a cool idea. I don't think I'd seen something like that before on 52. Yeah, cool. Should we keep on going?
Let's do it. Yeah, T11. Do you have any specific parts of the code? Because this is quite a chunky contract, right?
Yeah.
I think maybe
let's go straight to, let's skip the configuration part and just go straight to the kind of deposit withdrawal administration logic, which should move quicker, hopefully.
Do you have a line for me? There we go.
Right there, yeah.
Okay, so we just have two events. So deposit gives us the account, the user, and then the underlying amount, and withdraw, same thing. All right, take us through it.
Oh, okay. Incidentally, why index only the first argument in the events? I noticed by the events in general, you're indexing, I think it was the address, but not the amount. Is there a specific reason for that?
Well, yeah, index makes something kind of more searchable when you're querying. I don't really plan to like search by the exact amount someone has deposited something. I mean, maybe there's a case we need to do that. But yeah, I think I usually index like addresses who interact with things, because there's a chance you might want to be like, oh, like what are all the times someone deposited into this contract? And that's a case where you want something to be indexed. And then I usually just tend to put the users associated with actions first. So kind of naturally works out that way.
Cool. All right. So let's take a look at deposit. So we've got someone who's depositing an asset into here. It has to be more than 0. Incidentally, about that check, require underlying amount not equal to 0. I'm going to guess not equals is cheaper than greater than.
I just learned this, but Rari, the Solidity compiler dev, that they're actually, at least with 0 as a constant, it is equivalent to greater than.
Okay.
But with any other number, so like if you were checking that the return length of something is like 32 bytes, which is like the EVM word size, doing does not equal 32 to like check if it was like invalid is definitely cheaper than doing like, is less than 32. But in the case of 0, it is not.
Interesting. I also wanted to ask, I've seen some discussion around checks like this. Like, imagine if a check like this was not there. What would happen is a user would be able to deposit 0, but I'm assuming the math should still work out underneath that doesn't do anything bad, so to speak. Probably will revert even on safe transfer from. Essentially, a check like this is checking either for a user error or someone who just doesn't understand how to use the system. But it also then confers a cost to anyone else who's calling the function properly because they still have to pay for the check. How do you feel about checking for things like this?
In general, I'm like, fuck it. The user should get screwed. Like, I think that the performance of the code for users who aren't stupid, like, matters. That's why the ERC20 implementation in Soulmate doesn't try to stop you from transferring in the null address or the contract address. Like, if you're going to do that, like, that's your problem. I'm not raising the cost for everyone else. But in this case, there are some kind of interesting vectors from transferring 0. And one of them is like you can spam the deposit event without committing any tokens. I guess you could do that with one way too, but it's just something to think about. And then the other thing is it kind of creates some weird invariance when we're fuzzing this. So when we're spamming it with random inputs to make sure that the user can never, like a deposit call should never be successful. This is the invariant we defined. Like someone should never be able to call deposit without approving any tokens to the contract. And that should check out, right? But when we actually went and ran that invariant through a fuzzer, what it came up with was, if we deposit 0, then with certain tokens, they're actually gonna be able to call deposit without approving any tokens. So it's kind of gross from the invariant perspective to have to like filter out 0. But yeah, I'm still kind of conflicted whether or not to leave this check in. I'll probably reconsider it before it goes into prod.
Interesting. Incidentally, just because I don't know if we're going to get to it otherwise, are you allowing permits here, or you're only doing allowances? Like straight approval allowances?
Well, permits are kind of just an abstraction on top of setting allowances. Like under
I should have said approval allowances, like straight approvals.
Yes, since this inherits from Soulmate ERC20 and Soulmate ERC20 implements permit, this supports permit.
Very cool. All right. So what do we have here? We have mint, which mints to message. All right, because here, right, they're calling directly. So you give it to whoever's calling the function, underlying amount .fdiv
you
exchange
can
rate.
see that those fixed point math functions coming in here. You can see the fdiv. So what that's doing is it's basically like division, but accounting for the bases, and that's shown with the base unit there. We're saying like, okay, scale this down by our contract's base. And you're kind of dividing the amount of underlying tokens like DAI by the amount of tokens per RV token, so per RV DAI. And since that exchange rate only goes up, in theory, like at the start of the contracts, the vaults operation, it'll be 1-to-1. So you deposit 1 DAI and you'll get 1 RV token. But as it begins to earn interest, you'll deposit 1 DAI and that'll divide out to like 0.909 RV DAI.
Java Crypto is asking in chat about custom errors in Solidity 8. Is there a reason why you're not using custom errors yet?
When I started writing these, like the tooling was just not there yet. I still think it's partially not in the front end. Honestly, it's just like I haven't really pilled myself on them yet. Like I find the lack of a require syntax to be a bit gross. People have been saying that the gas cost is is cheaper, but I believe that's only on the revert case. But yeah, it's honestly, it's like I haven't really thought about it yet.
Fair enough. It's hard to keep up with, like, the bleeding edge of absolutely everything in Solidity also. I have seen Polberg's been on a bit of a tear recently that everybody should be using custom errors, so it's made me start thinking about it a little bit more too. Yeah, okay. So then you do your event, and then after that you do the transfer. This is a pattern I saw in your code a bunch, that you'll emit the event before doing the transfer. I'm usually used to events being the last thing people put in. Is there a specific reason why you're doing it before the transfer?
It's kind of like hyper zealous, like checks before effects compliance. So like you usually don't want to safe transfer from is the only thing in here that's an external call. So that's gonna, in theory, allow people to do arbitrary execution with something like an ERC-77. So even though I don't like, to the best of my knowledge, I don't think there is possible reentrancy here. If there was, I don't think it could be used to steal tokens, but at the very least, it could be used to spam the deposit event too many times, which could mess up front ends or other monitoring software. So it doesn't hurt to kind of keep external calls all the way at the end, including, events.
Very cool. Cool. All right. I guess one of the things that's really nice about this also is just, it is at the end of the day a pretty simple function. We're talking about 4 lines of code inside deposit. And that's really the whole thing. You take the amount, you mint the amount of tokens that the person's supposed to have, do the transfer, and you're done.
Yeah.
Well, I guess
it was something I kind of almost tore my head up about, which was if you kind of factor out the exchange rate function here into, if you inline it all and then remove some of the duplicate calls that happen within there, you can save like something like 600 gas or so. But it like absolutely destroys the readability of the function. And in this case is one of the cases where I just decided, I was like, the readability was actually more important here. And I think
I hate to be blasphemous. 600 gas is something like 17 thousandths of a cent or something. My ballpark right there. I think that's a small price to pay for readability.
Yeah.
So yeah, that's me. That is gas optimization blasphemy right there. So I guess, take it your own risk.
Oh, I've gone crazy over far less. Just.
Yeah. All right, cool. So withdraw, I'm assuming, is kind of like the flip side of this. So we've got the require again for 0. Then you burn the amount of tokens. So what's getting passed here? The underlying amount, as in for withdraw, you pass in like how much DAI you'd like to get out, and then it makes the calculation based off of that, and it figures out how much RV DAI to handle. If the person puts in more DAI than they're able to get with their current RV DAI holdings, I'm assuming the burn function itself is where the revert would happen.
Yep, and that's put in a comment right above burn. I spelled that out explicitly after the mini audit.
I can read. I'm sorry.
No, that wasn't meant to be a show up. I'm just.
So you go for the event, and then you have transfer underlying to. You can't just use a straight transfer.
Right. Let's skip to that function. Redeem is very similar. Transfer underlying to is kind of the start of the bulk of this function, of this contract. So what this does is, you noted correctly that in not a lot, but in some cases, we can't just do a transfer because transfer only moves the funds that the vault has just kind of sitting idly in it. But ideally, most of the vault's funds are sitting in a strategy, earning interest in compound or fuse or some other interest strategy where they're not freely available in the vault. So in the case of the user is withdrawing more than is just kind of sitting idly in the vault, we need to pull it out from our strategies. So that's what this function kind of handles. It calls total float, which gets the balance of the vault just kind of sitting in there. It then checks if the amount they're withdrawing is more than the idle amount. And then in that case, it kind of figures out the exact amount we want to pull and then does this pull from the withdrawal queue function which kind of loops over all the strategies and gets rid of the amount of funds we need and brings them back into the vault.
So sorry, I spaced a bit there. How does it figure out which strategy to pull from? If there's, I mean, do you have the? It does look like there is the ability to have more than one strategy per vault. So how's it picking where to pull from? Does it just go from like a most recent first kind of thing?
Well, let's jump straight to that function. I'll talk about it while we're going there. Pull from withdrawal.
Pull from withdrawal queue.
Yeah, so the interesting thing about the vault is that it doesn't actually have an array that's like all of my strategies. The vault actually, there's no requirement in the vault that it has to ever know about any of its strategies in theory. But we do need some ability to kind of see, in the case of withdrawals, at least some of the strategies we're in to allow kind of whales to withdraw some of their balance. And that's managed via this withdrawal queue array that we have. And the array is ordered last in, first out. So that means, array.length -1 is the thing that's first going to get removed from the queue. And array index 0 is the thing that's going to get removed last from the queue. And the queue doesn't have to be comprehensive over the list of strategies. And that's actually intentional, because there are cases where, say, we're like committed to a strategy for like we're time locked into it, or we've actually like made an agreement with a partner that we're keeping funds in the strategy for X amount of time. So that's kind of a useful feature. And then the reason it's ordered in that odd way, where we have to traverse backwards over it, is because removing things from the end of an array is much cheaper.
Significantly cheaper. Yeah.
Because we have to shift everything over. Versus only having to basically decrement the length of the array.
Very cool. Cool.
Yeah, so this function is pretty, this is kind of the meat, but really what it does is it just goes backwards through this queue. It says like, how much do we need to get the amount? We're kind of desiring the underlying amount. It pulls the maximum it needs from each strategy. And then it kind of interfaces with the strategy. It calls withdraw on it. And then it lowers the kind of internal balance for the strategy and all that jazz.
Would you say there's also a financial reason to go for draining the newest strategies first, or does it really just work out as a solidity optimization?
Well, the thing is, the queue is not managed by the contract at all. It's managed entirely off chain. So there's no guarantee that things at the end.
Okay.
Yeah, that's where it gets really weird. So like, yeah, like you can add a strategy to the vault without, and then the vault doesn't necessarily add that to the queue. But yeah, in practice, it works out that way. Like if people are committed to keeping the queue mostly up to date, then the newest thing will be.
I see what you're saying. So it really does just come out to a solidity optimization. That it won't necessarily be picking the most economically sound strategy to remove from, like the one that's making the least yield or whatever the case may be.
Right.
Like really, since you don't have guarantees.
Right, and that's another reason we do the queue management off chain and have the on chain contracts have no involvement, because there might be some complex ordering scheme that we could never implement in the vault itself, and there's no point in even trying to have the vault reorganize the queue itself when we can just do it one click off chain. In the case of what you're talking about, like, oh, if you were to withdraw from this now, we'd incur a loss of whatever.
Got it. Very cool. Very cool. I just wanted to jump in there. Sorry, I haven't been on mute because we've got some very young kids around. As an aside, is Rari hiring any young Solidity?
Yeah, I was about to say, if you're saying that, you've got to throw in something on the side. You know what I mean? Read the code base over your shoulders. Yeah.
I'll ask them if they can optimize an ERC20. But yeah, I'm very glad I got my little Rari chime in there. But yeah, I was going to ask, is there any sort of like high level comparison you can make between this vault logic and the logic that Yearn does with their vaults? Are there any obvious differences that you would point out?
Yeah, I mean, these vaults are very similar to Yearn's. They're kind of heavily inspired. I learned a lot from Doug, or Storming OX, I think, as he goes on Twitter. The kind of main difference is, one, obviously this is written in Solidity, not Viper. The second is that, so our vaults are oriented around lossless strategies, so like just depositing and lending markets for the most part. And they're also designed so that the strategies are kind of more low maintenance. The strategies themselves aren't expected to be super stateful. They kind of just do their little wrapping around another protocol and don't really have a lot of self-management logic. Whereas in Yearn, strategies are expected to kind of talk to the vault whenever they're reporting gains, and then the vault also has a lot more management in how it allocates new resources to them. Like, it has this kind of auto pullback and deposit thing, whereas our vaults to have a kind of, the vault reaches out to strategies when it needs them model, and it also has less involvement around how it's distributing funds to the strategies.
Awesome. Yeah, thanks for that context. Especially, we've actually got an in-house upskilling project going on now. One of our devs, where her assignment is to sort of create a very simplistic clone of a Yearn vault with two strategies, like a wide dive vault, essentially, with the Arbe strategy and a compound strategy. And we had to sort of go through Viper code, which none of us are that familiar with. So potentially we should all just look at this, right? And if we're going to do it in Solidity, we should take a lot of inspiration from your vaults.
Yeah, I don't mean to toot my own horn, but yeah, I think so. And I think that there are some parts of the Yearn vault's code base that it took me a while. Like, I don't think the thing about that code base is it wasn't written in one go. It's a very kind of naturally evolving system that has just come from their experience in prod, and some of the kind of very core elements were kind of slapped on in a rush and a PR. So some of the things, like the degradation coefficient in there, which is very hard to explain, and the comments don't do a good job at it. They're actually like contradict themselves at points. Yeah, I think we do a better job in here. No offense.
Nice.
Yeah, sometimes that is the second mover advantage. Yeah, I could hear that.
Oh,
sure.
I do realize we're pushing up against time a bit. We're both able to go overtime if you are also, but I mean, I do want to be conscious of just your own
yeah,
time
let's
frames.
do it. I got
no
problems with that.
Cool. So just actually, also just directly addressing a question in chat. The way that you do your for loop on 693, I don't think I've seen that before. I'm assuming it would be the same thing as just doing doing Uint 256 I equals withdrawal q dot length semicolon I is greater than or equal to 0 I minus minus. But yeah.
Yeah, it's basically just saying like the semicolons represent like that they're basically they're breaking up the parts where there would have been like a Uint 256 I equals and a kind of like, I is less than whatever, and instead we're just saying the only thing we're doing here
that makes a difference here.
Any declaration, we're not doing any checks. We're just decrementing this thing. We're just doing an effect.
Right. But since you have current index, and current index will throw if it goes beneath 0 anyway, like it effectively functions as like, right. I is greater than or equal to 0. Yeah. Cool. Cool. All right.
Yeah, confusing syntax. I like the way Rust does things, where like you can just like things kind of just return and they can be used kind of more broadly. It's annoying that Solidity just kind of forces you into like fitting the for loop syntax, though it's not too bad.
Cool. So then we pull out a strategy from the queue, get the balance from the struct to the strategy. Right. So then there's the trusted field in the strategy, which really comes into play here. If it's not trusted, it gets totally popped. So I guess trusted means that... Can I figure this out? Currently untrusted or was already depleted. So if the strategy is empty, you can pop it off the queue because it doesn't really do anything there right now. Is that right? Oh, right. Since the queue is only really being used as an accounting mechanism from inside the vault, if it doesn't have a balance, it can be popped off. What's happening with the trusted thing here? If the strategy is trusted or untrusted, what is a trusted strategy or an untrusted strategy?
Yeah, so there's kind of a two-factor auth kind of thing going on with how strategies are kind of authorized by the vault. So first, for the vault to deposit into a strategy, someone has to call trust strategy on it, and then someone can call deposit into strategy on it. So part of that reason is because it makes it really simple to manage vaults just from EOAs without other kind of wrapper contracts on top of them. Like we can just give someone the role to trust new strategies and give another person the role to deposit into strategies. And then we know that the person with the deposit role is never going to be able to rug the entire pool. Worst case, they just move it to a bad strategy or, a non-profitable one. While the person who has the trust key has to be a lot more careful. And then the other reason for having that kind of two-factor auth is if a strategy goes malicious or is out of order for some reason or is reporting something weird and we can't withdraw from it, we can kind of just shut it down and we can say, like, don't allow any vault interactions with it. And we call that distrusting. And that's when you disable trusting while the vault still has a balance. And that will prevent the vault from updating any accounting based on that strategy, performing any withdrawals into it, performing any new deposits. Yeah. And then the reason we're kind of checking it along with if the strategy balance is 0 in this if statement is, again, the vault doesn't do any kind of checking on what the queue is. So the queue could be full of strategies that are not even strategies. They could just be random addresses, or there could be duplicate strategies or strategies that have no balance. So the vault needs to kind of filter out strategies that are just like unworkable. And that's what this kind of line is for.
Cool.
And the reason we don't do that up front is because it's not too bad to do if we're just like inserting a new strategy at the end of the queue, but we have some operations where we just wipe the entire array and then just like set a new one. And then in cases like that, right, like looping over the whole thing is not really something we want to do. We want to be kind of optimistic about how the queue is being managed and not have to kind of check everything that the admin does, only at the last possible moment.
Cool. All right. So then after
one last thing, sorry,
yeah.
I hate to
go for it.
One thing that might surprise kind of optimizers here is like it looks like we're reading from the struct twice. We're doing get strategy data, strategy.balance, and strategy.trusted. Isn't that going to be 2 S loads? That's something I would have said like 4 months ago. But the kind of interesting thing about the optimizer is this is like one case that it optimizes double storage reads properly. No offense, but this gets just converted into the equivalent, which is like taking the kind of struct return from that mapping and like putting it into a memory struct and then just reading fields from the memory struct. The optimizer
on 695, right? Like on 695 when you declare strategies, so that's already pulling it into memory and you're fine after that, right?
In that case, strategy is like not a struct. That's just an address. So there's like no memory pulling in there.
No, this is a 698.
Whoops.
698 and 701, hey?
Yeah, those are the 2 reads. Okay, so I see what you're saying now. I missed that.
Yeah. So yeah, it's like an interesting thing that like looks like it would be actually really gas smelly, but it's not. And I like the kind of not having to introduce an extra data type there or an extra like thing in the scope that's like, strategy data. And then you're like, oh, where did the strategy data object come from? Like this makes it very clear and it doesn't have any gas costs, which is nice.
Cool. All right. Cool. So then pulling after the for loop. Yeah, were you going to say that?
Sorry, no, keep going. I was going to ask about the unchecked part because I'm pretty interested to dive into some sort of assembly, but this isn't really assembly here, I don't think. But yeah, we'll get there. It's fine.
I mean, yeah, there's just only one line in between there, like here and there anyway, which is just figuring out how much needs to get pulled based off of looking at how much is left also. which is, I mean, like you have in the this time I read the comments, which is how you have a guarantee that you're not going to go under 0.
Yeah.
Okay, so with that, this next harvest would count the withdrawal as a loss. So what do we have here on 720? Get strategy data, strategy dot balance equals strategy balance after withdrawal.
Yeah, I
Save
mean, it's
cash
kind of,
to
the comment is like almost confusing you more if there wasn't a comment there. But it was kind of a relic from when I was trying a different coding style of just saying the why and not the what. I don't follow that very consistently. But basically, like, all that's doing is kind of doing exactly what you'd expect, which is like, if we're removing funds from the strategy, we have to update our internal balance of the strategy. Like, it doesn't have those funds anymore. We're just lowering it. The only surprising thing there is there's a safe cast. That's from Soulmate Safecast. The reason that's there is because the strategy balance after withdrawal is computed as a 256-bit integer, but we store strategy balances as 248-bit integers, which is because
and encode something in the other 8 bytes.
Yep, we pack it with whether the strategy is trusted, and that's 8 bytes.
Got it.
Of a bool. Yeah, so that saves us a full S load in a lot of these cases. So it's worth doing and just in case, I mean, there's like very little cases where you need that extra 8 bits for the strategy balance, but just in case, for like correctness, it costs like 30 gas. We do a safe cast.
I just have a quick question. Is that sort of a prerequisite to get this little gas optimization on the 2 S loads here? Do both of these need to pack to 1 slot?
Well, for that, no, it should be equivalent even if it doesn't cleanly pack, because it's basically equivalent to just storing a memory copy of the whole thing. Yeah, so it's not really a prerequisite, but it's definitely like, if you're doing structs, there's probably a reason you're doing structs. It's probably to pack things.
I see. So actually, you're getting the full struct here in 1 S load, but then you are getting just gas optimizations other than that with the packing to 1 slot.
Yeah.
Sweet. Onwards then, I suppose.
Yeah.
And this is all in unchecked. What are the effects of this unchecked here?
Yeah, so unchecked is basically ever since Solidity 0.8. It does underflow and overflow checking, which is great because you used to have to put ugly libraries all over the place to like do it yourself. But there are cases where we don't need that protection, right? Like if we're adding to a counter that is, from like, it literally just goes up by 1 every time someone sends a transaction, there's no way that's going to the max 256-bit integer, which is like some massive number. Like, even after the heat death of the universe, if everyone on the planet was calling increment, no one's gonna every second, till the heat death of the universe, nowhere they're getting to that. So there's some case where like, okay, Solidity, you're being a bit overzealous here. We're gonna turn off your kind of checking. We know it's best. So some of these interactions here are those cases. So for example, above, we already checked that amount to pull is never going to be greater than the strategy's balance. So we don't need Solidity to check if we're going to fuck up there because we know we didn't fuck up. So we give it an unchecked to avoid that. And then in the case that we're lowering amount left to pull, it's the same case. Like we validated above that we're never going to pull more than the amount left. Yeah, so that's why we wrap that whole thing in an unchecked.
Does the unchecked affect the kind of non-math things there, like the event or the require?
It does not. The reason we do that locally is because so we need to access some of the intermediate values we compute in there in those other things, like in the final if statement there. There's no math we're doing in there, but we still need access to the strategy balance after withdrawal. Yeah, you could hoist
I guess.
Yeah, you could hoist out the variable like outside of unchecked and like set it to 0.
Initialize it before something, yeah.
Yeah, but the thing is, then you're doing, at least if I recall, you end up doing a double stack push, but it's also just ugly, and I prefer to keep
Mhm.
things nicely encapsulated like this. If I don't, there's no reason.
Interesting.
And unchecked isn't leaky. It's only at the top level scope. So like if there was a function call in here that like had math in it, like an external call or like another local call,
It doesn't
unchecked
uncheck over there also. Oh, that's
No,
cool.
it doesn't.
Uh-huh.
It doesn't do unchecked over there, which is
Yeah,
why it's
yeah.
like
Right.
batch things. Yeah.
That's awesome, man. I'm learning so much just from this stream. Thanks, man.
I'm glad to hear it.
All right, cool. So keep on going.
Let's do it.
Let's go.
Oh, actually, before you scroll down, though, one of the things, just like kind of perusing this quickly, the require on 729, I didn't really understand what was going on there. It looks like you're calling a function that should be returning 0 because you've already done the withdrawal, and then just
This is sorry. I don't want to like. I'm just gonna cut you off because this is like something.
Yeah, go for it, please.
Because it's a weird implementation detail. One of the kind of design requirements for this was strategies should be backwards compatible with C tokens, like compound C tokens. We shouldn't have to implement a wrapper there. It's odd, but it's because Fuse is a fork of Compound, and we want to be able to use Fuse tokens as primarily as strategies without a wrapper. And the fun part about C tokens is instead of reverting in a lot of cases, they return an error code, which like Max Wolf, I'm sorry, but this is the dumbest shit you ever came up with. Like it's a horrible idea, and Trail of Bits said that on their audit report. But they kept it nonetheless, and developers are still paying for it. So that's why we're checking if redeem underlying equals 0. We're basically saying if the error code is 0, meaning there is no error code, then we know that the redeem completed successfully.
got
But
it.
In some cases, like if I don't know, the market was overutilized and we couldn't redeem, instead of reverting there, it would just return an error code of like 32, and it would revert and fail here.
Is that in the weird ERC20 library? Are you familiar with weird ERC20?
By David Terry, of course I am. I love David Terry.
Did this make it in there?
I'm
like checking it in another window.
These aren't ERC20 functions. These are like C tokens.
Oh, I see what you're saying.
Like the actual transfer functions are completely standard. They're returning.
Got it.
Though, fun fact, returning a Boolean from a contract, there's no way to tell, like, if I returned a uint from a contract, or from an ERC20, like the transfer function, I returned a uint of 1. There would be no way for you to tell as a recipient
if that's a 1 or if it's a Boolean.
That's a 1 or a true, because at the end of the day, it's a 32 byte, and I had Open Zeppelin like tell us about that in an audit. Like they were like, FYI, you might want to let your users know about this. And I was like, are you fucking kidding me? Like, what do you want me to do? Change the EVM?
Dude, I'm loving the drama now between the auditors and the gas optimizers.
I mean, if we're paying them these ridiculous amounts, they can take the criticism.
Yeah, I agree.
I feel like I have to put in this that I was once talking. You know what? I hope he doesn't mind me calling him out by name, but I was speaking with Alberto Cuesta once, and he told me that when he was getting into the space, he would send things to different auditors and purposely put bugs in his code. Just to see what they'd get. Yeah, just like booby trap his code. I was like, and he's like, well, I wasn't very impressed by all of them.
Oh my.
Yeah.
The real learned skill is figuring out which market, like all the auditors they have different varying levels of marketing and different varying levels of actual talent, and like cutting through which ones, like there's a lot of mismatched expectations for firms from what I've picked up from CT.
Yeah, I mean, recently, okay, we can go on with the code soon, but I just thought it was worth bringing up. You see the, was it the Grim Finance hack, where it was just straight up re-entrance?
Oh gosh!
And it was like Will, do you remember what they said about the audit process?
Yes, they said we were in a period of growth, so the only person who audited this was a junior who didn't really know how to audit, and that's why we missed it.
Oops.
That was like their literal reason, though, and nobody reviewed it.
Oh my.
That was like their literal reason, which I'll admit, like I usually don't comment directly on these things because I really do enjoy staying out of politics, but I don't know. I had a hard time with that one.
Yeah, I mean it's tough, like especially for new devs coming in this space. Though I don't feel like people necessarily deserve shame for not getting code a $100,000 audit and waiting 6 months for it. But
I don't blame the
claiming
dude.
that you
I
have
blame
an
the whole
audit and you
company.
don't. That is the
Yeah.
problem. Like claiming
Yeah,
that
like
information.
how do you let that happen if it is the case? You know, like, okay, this could hold millions of user dollars that would never be able to be returned if someone were to exploit the contract. Let's give it to the guy who joined 2 weeks ago. Sounds legit. Like, how does that happen without a review? Like, that's in my mind where the problem is. I mean, for the poor guy who missed it, I feel bad for him. But I mean, oh
At least you
man.
didn't name drop them. They're like, at whatever on Twitter, and here's the ad. Review. If you're looking for interns, he's fresh on the market.
Yeah. I put it this way, that dude, I'm sure he's gonna know Solidity a lot better now.
Yeah. No, the best way to learn is failure, and I mean, fucking learn that firsthand. Welcome to Rari Capital. I mean, I'm just to say it. I didn't write. I wasn't even writing Solidity really at the time. I mean, I was, but not like for production code. But nonetheless, it's made me a lot more careful. Like, oh, this can happen to us with audits. Like, it's got to be a part of your process, not just something you think about at the end.
Mm-hmm. Yeah. Cool.
Dude, I think Ben disconnected.
He may have. He's been having some internet issues. The truth is, we are also like 20 minutes over time, so it could be that I might even take that as a little bit of an opportunity and say, like, we weren't able to make it through the code. I think one of my big lessons, having started this, like, with Rory and Ben, is that 1 hour is oftentimes not enough to do quite as much as we'd like in terms of reading a contract. But it was really awesome just to be able to dig into the stuff that we did. I'd love in my own time to sit down with the strategies more and figure out like how the strategies are recording and how they're interacting with the vaults and communicating and all of that. But if it's okay with you, maybe we'll cap it over here for now.
Yeah, sounds like a good time.
All right, awesome. Listen, I definitely want to thank you a ton just for coming on, leading us through the code, pointing out when I didn't actually like read the comments and all of that.
No worries.
Yeah, it's just always funny when it's like, putting on my intelligent voice. I'm like, aha, so this function must be. You're like, yes, I wrote that. But yeah, that's just part of reading code and things like that. Also, thanks a ton for coming on. This is probably going to be our last episode of. Is this our last episode of 2021? Are we doing anything on Friday, Rory? This is the last one.
Wow.
Oh, my Twitter is absolutely awful. Jabba Crypto is asking me what my Twitter is. It's William with some obscene number at the end of it because I didn't understand how to use Twitter when I made my account. I think it's, oh gosh, oh no, just type in William and look for a dude with a hat like this, and it should be something like that. 940 something or another. But yeah, I appreciate that, and yeah. I guess that's going to be it for us. Thanks a ton for joining us, everybody, and see you next year.